Here's lesson number 2. What we're going to do is we're going to create a, a pneumatic schematic in Fluid Sim. Anyone that's taken this course will have access to Fluid Sim, but if you don't, and let's say you're in Ireland or Mongolia or something and you want to play around with Fluid Sim, that's not a bad idea. It is the best. Well, you know, that's not true. There is another good mechatronic simulator called Automation Studio out there. So I'm not going to lie, but Fluid Sim is a good one. What is Fluid Sim, first of all? It's a way we can draw the actual pneumatic schematics. We can draw them and we can actually run them and see what's going to happen. So your lab tonight is going to be to create a pneumatic schematic, or a nice simple one, nothing crazy, an electro-pneumatic one. So what we're going to do is, see, I'm moving ahead too fast there. Now, I don't have a clue what half these buttons do, all right? But I just created a new there, and I have a new palette. Here are your symbols, all right? So let's not go crazy. What you're going to do is you're going to click on pneumatic, and we're going to get a single acting cylinder. We're just going to drag it out. If I want to zoom into that, I'm rolling my, if I hold down the control key and use my middle mouse button, I can zoom in and out, and I can click on this, and it gives me all the information on that specific cylinder. So that's that. Look, all these different, look at these fancy ones. A linear drive, very nice. There's your rotary actuator. Anyway, so we have one cylinder. That's the first thing. The next thing we're going to do is we're going to get a compressor. All right, and then we're going to get an air service unit, just like that. Okay, and I'm going to bring this down. I'm going to hit the control key and zoom out a little bit. That's about right there. And then notice how I can drag this up to there. Look at that, not beautiful? So air is going to come from here, and I can click on that, and what pressure is it on? Its operating pressure is 87 psi. Don't worry about that. And the next thing we're going to get is a directional control valve, and we're going to get a mechanically operated one. And look at all this madness here. You're going to get a 3-2 valve. You're going to pull that out. And let's see if we can control. Okay, let's watch this. All right, I'm going to grab this little arrow and I'm going to connect it to there. Now, did that bloody do it automatically or not? I'm that brain dead now. I don't even remember doing it. Everything is connected. Now watch this. You know, air is going to come in through here. It's going to go through the little drain. It's going to go through this, no problem, the pressure gauge. It's going to come around here, and it's going to come up, and it's going to hit a brick wall, a blockage. Now let's press play. Okay, and look at this, beautiful 58 psi. Can we change this? I love it. We can change. Oh, look at that. The Germans. Fantastic. All right, now watch this. Not fantastic? So you can see how the air flows. I'm actuating it, and you can see it comes through. So all that confusion that I was putting you through in lesson number 1, if I had come straight to here, would have made way more sense. Can I adjust the force of the spring? I can. I don't even want to get into that. But you can see here when I let go of the DCV, this pushes it back. All right, so we'll do that. That's what you're going to do. Now, I want to be able to control the speed of the extension and retraction. So how do I do that? I'm going to go to flow control valves, and I'm going to get a throttle valve. It won't let me drag it out in simulation mode. Okay, so I'll stop it. I'm going to drag out the throttle valve. I'll click this. I'll put this in line. Now notice how I have to keep my finger on that button to have it to do now. I'm going to press play. Okay, now it looks like that throttle valve is doing nothing. So what I'm going to do is opening level. I'm going to bring that way smaller. Now watch this. And I can do that on the fly. Now, what's interesting about this is the air pressure is pretty strong, and the air pressure has been able to bypass that. But once the spring, it's a lot slower coming in. Notice that? So how can I do that? If I want to really slow this extension speed, I'd have to even bring this further. I can even do it more. Too slow. What I need to do there now, screw that coming back. That's a good extension speed, but my retraction speed is way too slow. So what I'm going to do here is I'm going to get rid of that throttle valve, and I'm going to put in a one-way flow control. So we're just going to control the speed of the extension, and the retraction can be nice and fast. Now let's see, does this work? And you're going to see how this is. Now I'd like to pull this down, and it's like I can pull the objects away and I can bring it back. Now air is going to come in through here. It's not going to go that way. So can I click on this? I have to run it. I'm going to bring this way down. This is going to extend really slowly, but it's going to retract nice and fast. Do you believe me? Look at the ball. See the ball? What I loved about pneumatics when I was studying in DCU 20 years ago, um, it was visual. I could actually see what the hell was going on. It wasn't like magic like electronics. Okay? So it does exactly what it says on the tin. So this is an example of a pneumatic system. Okay. Now what I'm going to do is we're instead of having to hold my finger on the button, we're going to turn this into an electro-pneumatic system. Okay. So hold on. So it would be nice if we could control this with some sort of electrical switch. Okay, and I'll show you what I mean. I'm going to turn this off now, the simulation off, and I'm going to zoom out a little bit. And I'm going to minimize this flow control business. I'm going to go to electrical controls, and I'm going to grab myself a 24 volt supply. You don't know this, so I need to tell you. In industry, so much is controlled by DC 24 volts. Sure, there's AC 110 and 240 and three phase, but anything that 99% of stuff that goes into a PLC, which is your brains behind everything, is going to be 24 volts, and you should be happy because you're not going to get electrocuted by it. Okay, that doesn't mean you need to be careful around it, but so 24 volts is going to be your electrical control. Now, um, what we will do, come on now, hold on a second. I'm just dragging these out, okay? And I'm doing this on the fly. I haven't done this in a while, let's say. Now, I think I'm in the wrong place here. I prefer these. This looks better. Okay, just like that. It's really the same thing. And what I can do is I can right click on that, and I'm just going to rotate it 180 degrees. I'm going to go back. I'm missing something here. So just forgive me for a second. Is it in supply elements? No. I'm just looking through these here, trying to find out what I need. Yeah, that might work. Yeah, we could use that, which I'll explain what that is in a second. And then we need some sort of switch. There we go. Now we're cooking with gas. A D10 switch that makes. Now we're talking. Okay, sorry about that. Um, I'm just going to move this down so we can see it all. You can see it all. All right. This stuff I'm after dragging in. Just forget about that for a second. What you're seeing here is a purely pneumatic system. There's no electrical business going on to it. This is electrical, okay? And I have 24 volts and I have 0 volts, okay? Don't get scared because I'm after bringing some electrical stuff into this. This is a switch. And where the hell did I get all this? I got all this stuff in electrical controls, and I'm in IEC and NEMA. My instincts is NEMA national. NEMA is the United States and IEC is Europe. I should know that I don't know, but anyway, it doesn't matter. Don't get hung up on that. This is a symbol for a D10 switch. You're going to see what it does now in a second. This is a symbol for a valve solenoid, okay? And what that is, it's part of this directional control valve. This will make more sense when we're actually in the lab. Instead of this being manually actuated, I want it to be actuated by a solenoid. Hold on a second. I know I'm gonna. Let's go to type in solenoid valve, pneumatic valve, and let's see if I can show you what it looks like inside. Image. It would be lovely if somebody cut one of these open. Oh, here we go. Oh, maybe. Um, this is what it looks like in real life. You can screw your own ports into this. This is the pneumatic section. I know this is a shite image, but anyway. This is a pneumatic section right here. This portion of it is the actual solenoid. And all the solenoid does, it's an electromechanical device. When DC electricity runs through it, it causes it to move. Okay, let me show you what a solenoid looks like now. It might make more sense. Looks like this. There's a load of wire in here that's wired round and round and round and round and round like an electromagnet. When electricity runs through it, it pushes this out. I wish I could get a nice little diagram of it for you. Like a normal instructor, I should have all this. Oh, this is, oh, come here. Here we go. James Rutter, fair play to you. Okay. This is nice, okay. Here we go. This is your solenoid right here. Okay. A switch, a battery, a crazy coil of wire. The crazy coil of wire creates an electromagnet which forces this core to move. Are you watching? Yeah, right. There you go. Come on. Beautiful. What is it? It's an it's an electromechanical device. It converts electricity into mechanical motion. It's the mechanical motion that's just shifting this from from side to side. Okay? Now watch this. I'm going to run this and I'm going to press the button and look what it does. Electricity flows all the way through my switch into this solenoid and down to 0. I can turn it off like so. Well, how come my solenoid doesn't seem to move this? There is no connection between the two of them. How do we do that? We need to find we need to find a directional valve that's solenoid operated that is 3-2. Okay, and that's what this symbol means. Let's get rid of this mechanical one. If I drag that in there, does it automatically connect? No, it doesn't. So I'll break this. It's not too happy that it's getting in the way there. And I'll reconnect it. I'm going to double click on this. I'm going to right click on this and it won't let me do it. Is this thing turned off? If I double click on that identification, if I double click on this, what happens if I right click and I go component description? No, I'm going to call these the same name. I need this label and that label to be the same. But before I get into that, let's not go crazy. Let's put in some text, because I don't want to get my hand slapped for not doing any labels. Let's see if I can do that though. All right, how the hell do I find text? Miscellaneous. Why isn't it there? Is this new text? Virtual measuring, insert. Where is the text? Happy days. There it is there, okay. What is my text? I want 1A1. Okay. This is going to be, so how did I do that? I want insert, no, I want draw text. I'm hitting this Control C, Control V. I'm going to call this 1V1. I'm going to highlight it, Control C, Control V. 1V2. It would be 2V1 if you had a whole other system on the same diagram. Okay, so this is 1V2. I can't remember what we call, what is the label for a compressor? Bad form, I can't remember. I need to pay attention. Accessories, I think it's 0. Is it signal input 1S1? Pressure lines, we're going to go with Z1 for the time being. All right. Z1. Boom. All right, now how do I assign a label to this? I'm going to right click, properties, electrical connector. Do I go 1M1? Oh, I think I'm in business. And then I go here, identification, part number, 1M1. Will I put that up here? No, I didn't like that. Show designation, identification, 1M1. Oh, we might be in business. Now these are electrically connected, okay? What's going to happen is I'm going to press play. Oh, be jeepers, I love it. Now the solenoid, this is going to make a lot more sense. We're actually in a lab. What you're looking at now is an electro-pneumatic system, a basic electrode. This is the electrical side of it. Very, very simple electrical side of it that's controlling the pneumatic symbol, the pneumatic schematic. What I want you to do now, you're going to write a text box. You're going to write down your name. If you're in my class, don't bloody email me if you're not in my class. You're going to write your name. You're going to write down lab 1 and the date, 1st of the 19th, 2021. All right, boom. And we're going to go print. What you're going to do is you're going to print this out. nice and big. It would be nice if it was centered. You're going to figure this out. I want you to put it on your, print it out, put it on your refrigerator, okay? To show off. Now, but apart from that, you're also going to email it to me. So you're going to save this as a PDF and you're going to submit it in the submission place in Canvas. Well done. All right, I'll see you next week.